Hello again. In this film we're going to have a look inside the receiver software and setting of fail-safes. So let's go into our menu, into Model and down to the Device Explorer. And it shows here we've got a Rex 10 receiver. If I had any XBus or XBus telemetry sensors, they would show below as a sort of subset of the Rex10, and it's also showing an RC switch. Don't worry that you don't have an RC switch. I don't, but Jeti always puts it there by default, probably because if you do have one, it's a bit of a safety issue. Not that it's unsafe to use, but it'd be some sort of safety thing to make sure it's set up. Right, let's go into our Rex10, and we get these. Obviously, at the bottom, reset to factory defaults should you need it. Let's go into General Settings. And here we have the output period. This is the refresh rate it will send data to the servos. Analog servos tend to like something around 20 milliseconds because that's what they were used to. That's what they were designed for. Jeti, for some reason, defaults to about 17 usually. I've left it there. I've not had an analog servo complain about it. If you have digital servos, they're happy with the slower refresh rate, but they can also take a higher refresh rate. Whether you and I would actually notice the difference is arguable, but there we go. It's there for you. You can set it to auto, if I remember rightly. Come all the way down, there's auto. Do not use auto unless you're using digital servos, because it's likely to, it has been known to cause problem with analog servos. So unless you're desperate to change it, just leave it at something like 17, 18, 19, 20 milliseconds. You happy with that? Right, the PPM settings, number of channels. This is to do with taking a PPM serial data stream out of one of the bus ports or expander ports on the receiver. So unless you're desperate to do that in order to run your little quad camera or whatever, don't worry about that or the PPM UDI mode. The alarm settings, low voltage alarm. This causes a lot of problems for people because in the transmitter, in advanced options, you can set alarms, and you can set a receiver voltage alarm in there, and people set themselves a sensible alarm setting and then wonder why the transmitter keeps chirping at them and squealing about low voltage. That's because here in the receiver there is also a low voltage alarm, and that can catch people out because they say, well, I've set the transmitter to a sensible setting, and why is the alarm still going off? It's because this one is going off. And I suspect the reason that this one exists is simply a legacy issue, going back to the days when there were no Jeti transmitters, but you could buy a module from Jeti to stick in your transmitter. Well, of course, if your JR or Futaba transmitter didn't have user settable alarms in them, so all you could do was set an alarm in the Jeti receiver to make the module chirp at you, and I think that's probably where this comes from. So it tends to default to 4.5 volts. Just leave it down there unless you're using a particularly low voltage battery, or if you like, just go into it and turn it way down so it's never a problem, as long as you're happy setting your own alarms in the Jeti transmitter rather than, although I'm doing this on the transmitter, we're inside the receiver, as it were. Okay, come out of there. Failsafe. Right, if you're in Britain, you are required by law to set a failsafe on throttle to prevent the model flying away in the loss of control if your radio system has failsafe capability. Now, the Jeti has fail-safe capability. Therefore, if you're watching this and you've got Jeti, you are required by law to set the throttle to idle, or stopped. The law isn't concerned what you do with the rest of the failsafe. The CAA just wants to make sure that if your model goes out of control, it doesn't sort of fly off and away climbing up into the full-size traffic. So make sure it's enabled. The failsafe delay, 1.5 seconds. My own feeling is that that's too long. I like that down at half a second. You know, something with an electric prop that doesn't want to stop, or a jet traveling at high speed, half a second can feel like an eternity. 1.5 seconds can feel like an eternity. So I like half a second, but it's your choice. We won't set the failsafe positions yet. We'll come back to that. Come down to out pin 1. That means socket number 1 on the receiver. It's set to failsafe because I've already set these up beforehand, but what you'll find is that all of them are set, I think, at hold by default. So what you have to do is for each one of them, go in and change it. In this case, this is throttle, so I do not want it to hold, because it could be holding at full throttle. Out off means it switches off the data at that socket. The power is still there, but having switched off the data wire, the servo doesn't know where to go. And so it'll just sort of sit there unless something pushes it. Hold means it sends an actual data to the servo to hold that position that it was last at. Output off, the servo will not hold a position. It will sit there until something pushes it. So it could be the airflow pushing something, or the vibration of the engine makes it rotate, whatever. So certainly in Britain, whichever channel the throttle is on, you must set it to failsafe. And then you've got to come down each one individually, setting every channel the way you want it. As I said, you must set the throttle to failsafe. Every other channel, it's up to you what you do with it. I like to set them all to failsafe, and I know what they're doing. Having done that, go to set failsafe positions now. Put your throttle to idle. Bring the trim back to kill the engine if you wish to. It depends on what your settings are. Put things like wheels down if you want. Wheel brakes on. That's the way I set my fail-safes, with retracts and brakes. Put your flaps, whatever, into the position you want. I tend to go for everything neutral, but it's your choice. Remember, the law only speaks about the throttle. And then press the dial button to set fail-safe, set all fail-safe positions, apply changes, yes, and there we go. And if you look down there, you can see the actual values that it's set. I've left everything at 0 except the throttle. Okie doke. So we can come out of there. Alternative pin configuration. Again, it's the servo sockets. If you have a look at them, they'll default to being a servo. But if you open it up, you see it can be a servo, a DTEX, digital output, or digital input. DTEX is a type of servo made by Hacker in Germany and also sold through the Jeti brand, which has telemetry from the servo, although they now start making non-telemetry versions as well, which are cheaper. But if you wanted your servo telemetry, you would have to set the socket to be DTEX, otherwise it wouldn't take the telemetry out of the servo. If it's of interest to you, you can get from the servo how much current it was consuming, what voltage it's actually seeing at its end of the wire, what the signal was, what its temperature is, what percentage of its output torque it was using at any one time, and so on. It's certainly very interesting if you have a model with massive services and extremely powerful servos and you're wondering just what's going on. Digital output and digital input mean on the data pin, you can treat it as like a computer signal, either a 1 or a 0. It's, I forget, about 3.5 volts, something like that. but very little amperage. So this is not for controlling a servo, but to control some digital device, which is just looking for a little 1 or a little 0 to trigger it. And digital input is simply putting it back the other way. For example, suppose you want the doors on your retracting undercarriage to close when the leg is up, and you don't want to use a simple timer sequence because these could be a bit variable. You could put a micro switch up in the bay so that the leg coming up closes the micro switch, and you've got a small battery with a little resistor and a current flowing through that back to this servo socket as a digital input. So now the socket will read a 0 or a 1 depending if the switch is open or closed, and you can telemetry that back to the transmitter and use it to trigger the sequencer or whatever to close the doors. So in the vast majority of cases you will use servo. You might use DTEX if you want DTEX servos. Okay, if we come further down, we see here in this particular case E2 means that port 8 is also expander port 2. As well as the EXT port, there's expander port 1 and expander port 2, which are for things like telemetry sensors. So as well as a servo, it can be DTEX. It can be plug in your Jeti box if you have one of those, or a telemetry sensor. It can be Jeti's X bus, which is a two-way computer type communication. X bus input back up and back, otherwise digital inputs and outputs. PPM positive out, which is an old-fashioned data stream. PPM inputs coming in, and again UDI is Universal Data Interface, 12 and 16 channels, where again you can output a whole stream of data, for instance going to a power box where you can take all your channels down there in one go, rather than lots and lots of different cables per channel. S-bus, I think it's the Futaba type thing. Further on down, there's expander port 1, and there's the EXT port itself, which will only take Jeti box or sensor. We come out of this and have a look finally at receiver outputs. So out pin 1, that's socket number 1. At the moment it's being sent throttle 1 on channel 1, and it's in group A. You'll notice there's, looking down the group, there's A, B and C. This is the sequence and groups in which it sends out the data to the servo. So it'll send everything in group A, gets its data at the same time. So throttle, flap, rudder, they're in group A. They'll all get their data and start to move at the same time. There's only the 3 groups. If during the setup of the model you had said it was a 2 horizontal, 1 vertical, in other words 2 elevator model, you would show in here it would have elevator 1 and elevator 2, and it's clever enough to assign both elevator 1 and elevator 2 to the same output groups, meaning that both elevator servos get their data at the same time, meaning they both move at the same time. There isn't a fraction of a second difference in them moving. Again, would your average person know the difference? Probably not, but it's particularly helpful when you have ganged servos, that is, a big flap or an all-moving tailplane, where you've got 2 or more servos driving it together, and you've got to be careful tuning them to make sure they're not fighting one another. Then it is helpful if they're on the same output group, so that they all start and stop moving at the same time. And you can change the group. You just go in there, change it to whatever you want needs be. Looking at the outputs, you can remap here. If I don't want throttle on output pin 1, I can put it on, or rather I can, come down, and I can put it on out socket 9 or socket 10. Why should I want to? Probably not at this stage. I could do it in the transmitter channel settings. I could assign throttle to channel 9 or 10. But there's also the option here of expanding things out without using throttle. Without using transmitted channels. For instance, if you had an afterburner ring, you could plug it into number 9 and map 9 and 10 to the afterburner, whatever. It's not something really that your average model is going to use. Where it did come in useful on one model I have a Central Box 400 up at the front of the model, which outputs an X-bus data stream down to a Central Box 100 at the rear of the model. But there's only a Central Box 100 has 7 outputs, and there's only very specific channels I wanted on those outputs, and some of them were like channel 12 and 13. So I was able to remap the channels I needed to the output pins 1 to 7, rather than just allow the sequence that they come in. So again, in your average model, this is not something you're going to need to bother about, but it's there should you need it.